Hello, my name is Lisha Soames and I work as an assistant professor senior grade in the Department of Computer Science and Engineering in Sri Ramakrishna Institute of Technology, Coimbatore. This video presentation is an assignment submission for the Faculty Development Program organized and conducted by IIT Mumbai on the use of ICT and blended learning. In today's video presentation, I would like to have a brief presentation upon the course Graph Theory and Applications. And in the presentation, I would just highlight a few topics like strongly connected directed graphs, weakly connected directed graphs, and the Euler digraph. So to recall, a directed graph, or it can be known as digraph, is a graph whose edges are all directed. So as we see here in the diagram, there is a graph. It's where the arcs are having some orientation, hence the name directed graph. So totally there are 5 nodes or vertices, namely A, B, C, D and E. The total number of edges that links every vertex to each other vertices are 1, 2, 3, 4, 5, 6, 7, 8 edges or arcs or links. The real-time applications of directed graphs are the one-way streets, the flights, task scheduling, and so on. The other important terminologies in studying a graph are walk, path, closed, trail, and cycle. Walk is nothing but a sequence of adjacent vertices V0, V1, etc. up to n. Vn is known as the walk. A walk for this given graph would be A, B, D, E, C, D. It's nothing but a set of adjacent vertices from V0 to Vn. A path. A walk in which no vertex occurs more than once is a path. So the difference between walk and path is nothing but it's a sequence of adjacent vertices concerned that no vertices occur more than once. Closed. A walk is closed if V0 is equal to Vn. If the start vertex is equal to the end vertex, then yes, the path is closed. So the given graph here in this diagram is a closed graph. The trail. A walk in which no edge occurs more than once is known as a trail. So here we can see the edges not repeating again. So no edge repeats more than once. So hence there's trails in this given graph. Cycle. A cycle can be defined as a closed path in which n is greater than or equal to 3. Here we may find a cycle between A, C, D. A, D, E and A. A, D, E and A represents a cycle. Now, let us see what's a connected digraph. So the connectivity in the directed graphs exists in 2 types. Either they should be strongly connected or they should be weakly connected. A strongly connected graph is one if there is a direct path from A to B and from B to A for n vertices A and B. Or in other words, a digraph is strongly connected if there is a direct path from every vertex to every other vertex. So if the given graph provided 5 vertices A, B, C, D and E. If you notice, there is a direct edge from every vertex of this graph to every other vertices in the C. A has a vertex to A has an edge to B. B has a directed edge or direct path to D, and D has to E, and D has to A. So they are strongly connected. If a directed graph is not strongly connected, and if and only if the underlying graph is connected, so the underlying graph here denotes without direction to the arcs, then the graph is said to be weakly connected. So if we could find here, there is no edge present between A and D, whereas there is a path that leads to D from A to B, B to E, E to D. But this link is missing. So we can conclude that these vertices are not strongly connected. The underlying graph of this graph would be this undirected graph. So this underlying graph is considered to check if all the edges are connected. Yes, and this is where we find again A and D has missing edge. Other examples for strongly connected and weakly connected are as follows. So this graph, there exists no path from E to D or from D to E. Hence, they are not strongly connected and they are not weakly connected. Whereas here, if you notice, all the 5 vertices are connected to one another. There's an arc from A to B as well as from B to A. There is an arc from A to C and then from C to A. And every other vertex has links to other vertices as well. E to C and C to A, E to D and D to E, and so on. So they are strongly connected. Weakly connected, yes, there is no path from D to any other vertex C. Now, the Euler cycles in Digraph. An Euler cycle is named after the great mathematician Leonhard Euler. An Euler cycle is a closed path that goes through each edge exactly once. That is, the vertices in the graph needs to be visited exactly once, where the starting point is equal to the end point. A digraph has an Euler cycle if and only if it is connected, and the in-degree of each vertex equals its out-degree. The Euler's theorem is stated as follows. A digraph G is an Euler digraph if and only if G is connected and is balanced. So, to explain the concept of connectivity is why I have been telling about the strongly connected graphs and weakly connected graphs. So here, G is connected. Yes, G is connected. G is balanced. Yes, G is balanced. Then there exists a digraph G, where the Euler cycle is present. Okay, so now let us calculate the in-degree of each vertex and the out-degree of each vertex. Now, if you check here, the vertex 1 has a self-loop and an outgoing edge from 1. So, the in-degree is nothing but the number of incident edges incoming, or the number of incoming edges, to make it simple. So the in-degree of 1 is 2. The out-degree of 1 is again 2. Okay, so here in-degree 1, B and C, 2. Outgoing degree C and D. 3 has one in-degree D and one out-degree E. 4 has one in-degree, that is F, and an out-degree A, that is 1. So in-degree is equal to out-degree. Yes, this graph has an Euler digraph. So thank you for watching. Goodbye.